As you can see, this is a warehouse design. This warehouse is designed modern and let me unlock it so that you see. This is 24 meter by 132 meter warehouse, designed with a tapered section, as you can see here. I go to the ZS, is it? This is the grid line. So let's proceed to the analysis. You can start the analysis, run the analysis. The analysis has been done. Let's view the Z. Where is the section? So the analysis has been done. Let's display the force, the frame forces. So we're going to be considering the dead load. So look at the axial force we apply. This is the maximum axial force. At least the maximum axial force at this joint is this. So we're going to be considering this grid alone. So let's consider the minimum shear. The minimum shear. Then the maximum shear force. There's no maximum shear, the torsion. This is the torsional force. This is the moment. So there's no minimum moment. Then we talk about the maximum moment. This is the maximum bedding moment at this end, at this end. No, this is a flange. This is a prismatic section, that is PEB. Tapered section. Now, the analysis has been done. Let's proceed to the design. Just come here. Start our design check. Now, this is how the design has been checked. This is the name of the column. Now, let's see the utilization ratio if actually any of the section is failing. So, come to the design. Still design. Go to our design formation. So, maximum stress ratio. Now 0.5, 0 for this instead of 1. So this is passing. Now these are the same information we use in designing. Before we go to model, you have to check the connection here. Now, so in doing connection, we are going to look. This is what I did. On the project, what we did before. Save this. This is the this. Now, this is the connection and the rafter and column connection. So if you look at this information, this is the axial load, this is the minimum shear force, this is the maximum moment. So if we come back here to this shape, let's see this information that I use in designing. This is the jet I considered. So we'll come to display, show force, come here. Now let's look at the axial force. So maybe this is not the exact grid I use. So here we have 50. Here we have 50.3, which is the axial force here. So I use 63.6 because I know I use another grid. You know the grid difference. So now let's say this is we are not going to consider. We are only consider here. So this is the only force we are going to consider now. This is for the hazard force. Then we'll come to the shear moment too. 46.5 here. This is 43. Understand? 43. But I use 53. I use 53.2, but in this grid line we're having 46. Now we'll come to the maximum shear. So I use the critical grid line. That is why any grid line I pick, the shear force is going to be lower than the one I use. So this is the torsional force. So the torsional force here is 0.2. But here I have 0.1. That is bigger than the one I choose. Now we come to the minimum moment, 0. The maximum bending moment at this point is 186.83. Here I use 228.4. So the one I choose is greater than. So since I said I use the critical grid line, so all my load is higher than the one I get from my analysis. Now from here we cannot proceed to the design. So in added statica, just calculate. Note I've already selected the bolt, the base plate. Okay, let me just calculate. Now from here, look at the plate. The thickness of the plate I'm using is 16 mm. So this is the spacing of the bolt. 1 to here to here we have 45, 1 to 5, 1 to 5, 1 to 5. Now, so this section already is based on the section I have in my sap2000. So that is that. So talk about this stiffness. The stiffness is 10 mm or 10 mm thick. So I've done that. We cannot proceed to calculate. So here we don't know if these parameters, the information are okay. So these are the same information we are going to use in technical structure in designing. We don't need to check buckling because we are majorly concerned about the moment I share here. There's no buckling. So you can see it's pass, the plate pass, the bolt pass, the wet pass. Now this weld now I use 6 mm. So it is welded on both sides. So if I choose here is one side and I can change the thickness of my weld. So I'm using 6 mm thick and it's welded on both sides. So this has passed successfully. So if I need this information, I can just go to my check again to see how it reacts. No, this is the boat that has the highest load is coming on this boat. So if we check about, if we look at the stress on both forks, so the highest force is here, 141.7. This is 9.3, 48.89.3, 48.4, 40.9. So as you are going up, the force is reduced because this is going to move like this. So the force is higher here. Now we talk about the mesh. So this is the mesh. Those of us who are very good in finite element analysis, they will understand more about this. So this is the deformed shape. So look at it. This height is going to deform up. That is why the movement here is the boat here is carrying a higher force. We restrict this boat from going up, but it's based on how I put this moment. You can see this moment, as I pull minus, it is going to curve down. So that is that, sorry. So that is that. Now if we check about the analysis, this is it. The plate, all the plate are passing. This is the boat. You can see the boat here, you can see. So the boat is passing. So the check has been complete. So let's look at our report. This is the major thing that we need to print or take or follow while designing while modeling this section in the technical structure. So this is it. So these are the information we majorly need. So if we need a full report, we can do a full report. So this is the BOM, bill of material, for this connection. So you can see this is the plate from 85, 125, 175, 135, 125, then 55. So this is it. We go to the detailed bill of material. So this statica is very good. So you don't just go to product structure. Product structure, you can put your connection, but it will not design.